Hello, and today we will be solving volumes for complex figures. So remember we did complex or finding the surface area of complex figures before, and we're going to be using the same figures for the volume. Okay, so the first shape that we'll be looking at would be a shape that looks like this. All right, so that looks like it's a combination of two shapes, right? So that part would be a rectangular prism. And that part would be a pyramid. And the concept is similar of how to find the volume of this shape. You can separate the shape into two pieces. So into the pyramid and into the rectangular prism. And you find the volume of the rectangular prism here. And then you find the volume of the pyramid here. And then you do the rectangular prism plus the pyramid. Okay, so that's our general concept. That's the strategy that we're going to be using. So let's give some measurements for these shapes here. So let's call that L here and that a W here. Let's call this length here H. Okay, and for the pyramid, to find the volume, you need to have this height here, the one that goes perpendicular from the vertex all the way down to the base. And let's call that one, let's call it L, since H is already taken. Okay, so basically our general concept, like I said down here, would be to find the volume of the rectangular prism. What is the volume of the rectangular prism? Well, you just do L times W times H. Okay, the formula for volumes are much easier than the formula for surface areas. I recommend you again not to just memorize the formulas, but to understand the concept here. You're finding the area of the base, which is L times W, and you're multiplying that times the height to get all the way up here, actually. So that would be the volume of the rectangular pyramid, or the rectangular prism. How about for the pyramid? Again, you need to find the area of the base here and then multiply that times the height, right? So the area of the base, this base right here is the same as this base right here. Those two are the same. Okay, so the base of the triangle there, or not the triangle, the rectangle there would be L times W. And then you multiply that times, oh, I should not use L here because I've used L for the length down there. Let's use X. I'll use X here. Which variable you use is not that important as long as you don't use the same variable more than once, which I did. So I'm changing it to X, and to get the volume of that pyramid, you'll need to multiply that times X. And remember, for pyramids, you need to divide by 3 or multiply by 1/3. Right? So you can get the volume of that shape right there with this method. Okay, I don't want to call this a formula because, again, I don't want you to just memorize this and plug in the numbers. But I want you to see this as a method of finding the volume. So this is the volume of the rectangular prism. This is the volume of the pyramid, and you're adding those two volumes together. Let's try another one. This time, let's use a triangular. It's a triangular base. But again, the concept is basically the same. All right, so the only difference here is that instead of a rectangular base that we had here, we have a triangular base. This base is in the shape of a triangle. And again, this base right here and this base right here are exactly the same. Okay, so let's call this. So that's the volume of the triangular prism. And you're multiplying that, or not multiplying, you're adding that to the volume of the pyramid, the triangular pyramid up here. Okay, so you're using the same concept as you did with the other shape here. And if you call this as B, for the base here, you need the perpendicular line there. Let's call that L, and let's call this H, and let's call this here. So for the pyramid, we need the perpendicular line. Let's call that X again. Okay, so what's the area, or what's the volume of the triangular prism for this part? That's the area of the base, right here, area of the base, times the height. Okay, so the area of the base is B times L times 1/2. You multiply that times height to get the volume of that triangular prism. What's the volume of the pyramid? You get the area of the base again. Since the bases have this, the bases are the same, we can just use the same base again. So B times L times 1/2, and you're multiplying that times X. That's the height of this pyramid. But because it's a pyramid, you need to multiply by 1/3 or divide by 3. Okay. So again, you're using the same concept. This is the triangular prism. This is the square triangular pyramid. Okay, so even though these two look different, the way that you get the volume is very, very similar. And the same goes with a circular base. Actually, I should use dotted line for that other half. Let me draw a cylinder here, like that. And on top of it, we have a cone. So you'll notice that in real life, it's very rare that you see a perfect cylinder. More often than not, you see a combination of some of the shapes that we've studied here. So it's very hard to see a perfect cube. It's very hard to see a rectangular prism. Right? You're more likely to see combinations of some of these numbers, some of these figures. So that's why we're practicing finding the volume of a combination of these three-dimensional figures. Okay, so let's give this guy some measurements. Let's call that R. Let's call this H. And just for consistency, we'll call this as X. And the way you find the volume of this shape, again, find the base. So you're finding the cylinder part, and you're adding the cone part. All right, so for the cylinder part, you find the base, which is pi r squared. We have a radius r, and the area of the circle is pi r squared. Multiply that times the height. Right, so that's the volume of the cylinder. For the cone here, again, you find the area of the base. And again, this base is the same as this base. So we can use pi r squared again for that base. You multiply that times the height, which is x. And because it's a cone, we need to divide by 3 or multiply by 1/3. Okay, so this is how you find volume of complex figures. The concept is the same. You just find the volume of each of those components, and then you add them together. Okay, so even if you see a figure that looks different from this, so just as an extra practice, let me draw a house here. It's a very simple looking house, and the roof is going to look something like this, right? These should be dotted, right? And you see two different shapes here, right? You see a rectangular prism. Oops. You see a rectangular prism, and you see a triangular prism. But the way you find the total volume is the same. You just find the volume of this rectangular prism, right? Rectangular prism. Let's call it RP. And then add that to the volume of the triangular prism. Triangular prism. All right, so let's see how that would look like. Let's actually, let's use actual numbers here. So let's say that is 10 meters. That is, let's say 20 meters. The height is 5 meters. And then for the triangular prism, we'll need this height right there. Let's say that is 3 meters. Okay, then what would the volume of this total shape be? Well, for the volume of the rectangular prism here, the red part here, you just need to multiply 10 times 2 to get the volume of the base, or the area of the base, right? Area of that base right there. And then multiply that times this height, times 5. So 10 times 20 times 5 is going to be 1,000. Right? And 1,000 meters, or meters cubed, I should say. Yes, by the way, please use the right unit for volume. And for the triangular prism, it's going to be, let's find the base here first. Okay, so that's going to be 10, right? That's 10 times 3, and then divided by 2, because it's a triangle. So 10 times 3 divided by 2. That's the base here, and then you multiply that time this much, right? That much, which is 20. So that is 15 times 20, which is going to be 300. And then you should write the volume unit here, and then just add those two together. So you're going to get 1,300 meters cubed for the whole volume, right? So as long as you're using the same concept, even though I had no idea what the formula for this was, I can use the same concept to find the volume of complex shapes. You just find the volume of each of those individual shapes, each of these shapes, and then you add those together.